When factoring the difference between two squares, there are a few things you should recognize about these kinds of problems. One is there are two terms. One term, two terms. Two is it's a subtraction problem, hence the minus sign. And the third thing is that both numbers are perfect squares. Perfect squares include numbers like 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144. These are all perfect squares because you can find numbers. Hence, for example, the square root of 16 is 4. The square root of 121 is 11. The square root of 49 is 7. That's what makes all of these perfect squares. So if you look at the example we were looking at in the beginning, one of the rules is that both numbers are perfect squares. In this case, 25 is a perfect square. Z squared is perfect because I can find the square root of z squared. And 16 is also perfect. Now once you've determined that all these things are true, you can that your answer is going to always look like this. If you are factoring the difference between two squares, the answer will always have one positive binomial factor and one negative binomial factor. So let's look at the problem in the beginning. So here's one binomial factor, here's the second one. That rule just told me that the answers will always have one positive and one negative. So we're going to have one positive and one negative. The second rule says that the terms in your binomials will be the square roots of the terms in the original problem. So let's look at the original problem and fill in our spaces. So what's the square root of 25? 5. What's the square root of z squared? Z. What's the square root of 16? 4. And that is always how your answers will work out. So let's take that and apply it to. There's one thing though that you want to look out for. This looks a lot like what we're doing, except there's a plus sign here. Okay? So if you see this, binomials, perfect squares, but instead of subtraction, it's addition. It's a prime. You cannot factor it. For instance, if this was x squared minus 81, then I would know that my answer is x plus 9, x minus 9. Now when you glance at this at first, you might think that this could be your answer. But when you FOIL it out, x times x gives you x squared. X times negative 9 gives me negative 9x. 9 times x gives me positive 9x. And 9 times negative 9 gives me negative 81. As you can see, the middle terms cancel themselves out, and I'm left with x squared minus 81. There's no way to get back to this. So you can't factor it. The answer here would be prime. And I just wanted to tell you that just so you can look out for it. But the problems on your test will be the difference between two squares. So here are some examples. Okay, first we want to make sure that it has all the characteristics that we need. Are there two terms? Yes, there's one here and there's one there. Is it a subtraction problem? Yes, it is a subtraction problem. Do I have perfect squares? 36 is perfect, t squared is perfect, 81 is perfect, and so is y squared. So that means right away I know that I'm going to have two binomial factors. One's going to be plus, one's going to be minus. And then find the square roots. What's the square root of 36? 6. What's the square root of t squared? T. So that's going to be the same exact thing over here. What's the square root of 81? 9. What's the square root of y squared? Y. As you can see, your binomial factors have the same exact terms. The only thing that's different is the plus and the minus. Okay, and it will always be like that. Let's look at the next one. 9s squared minus 25t squared. 9s squared, I have two perfect squares being subtracted. That means I'm going to have one with a plus and one with a minus. And I begin finding the square root. Square root of 9 is 3. Square root of s squared is s. Square root of 25 is 5. Square root of t squared is t. So, same exact terms. Only thing that's different is the plus and the minus sign.